Today we're going to be talking about algebraic proofs, and it's a really exciting day. I think I said that in a previous video, that now we're getting into the meat and potatoes of proofs. We're going to start some algebraic proofs, and we're going to start it really first with some algebra that you guys are used to. So we're going to kind of dip our toe in the water of proofs today, which I think is very exciting. Okay, so we had some properties, you have some properties of real numbers that you went through when you were learning how to prove, or when you were solving equations, and you didn't have to justify each step, but now in geometry, we're going to have to justify each step. So what I want you to do is I want you to pause the video, take a minute, and write down each one of the properties along with the example, okay? And then I'm going to go through a quick explanation of all of these, but I want all of these in your notes. Okay, so the addition property, hopefully it makes sense to you. You have A equals B, you're adding a number to both sides. Similar to subtraction, similar to multiplication, similar to division. Okay, reflexive property. This is going to be really, really important to us in the next chapter when we start proving triangles congruent. Symmetric property, sometimes I call this symmetry. Basically, you're just flipping the location of your variables across the equal sign. Transitive property. So if A equals B and B equals C, then A equals C. Because you have the same thing equal to the same thing, essentially. Substitution, if you have A equals B, you can replace A or B in any expression. And then our distributive property, moving through and distributing your values. Okay, so our first step, justifying our property. State the property that justifies. So you look at your original equation, and what's changed? They've added an x to both sides. So that's addition. If x equals y and y equals z, x equals z, that's the transitive property. This property here is reflexive. I distributed the 3 on through. It's exactly what it is. Distributive property. Okay, example 2. I have no directions on here, I just noticed that. We need to solve that, and we're going to justify each step. And what we're doing here is we're building the foundation. We're doing what we call a 2-column proof, where you have your statements on the left and the reasons, or our justification for the steps, on the right. And this is how we're going to be doing proofs. There's a lot of different proofs out there. In the last lesson, we did paragraph proofs. Our book also talks about flowchart proofs. And I like all the proofs. Just 2-column are the ones that I tend to focus on. They're the most common ones. So the first step in any 2-column proof, or any proof in general, is you write out what you're trying to solve. And your first reason is always the given. Second step, you do something with that, okay? Distribute the 2 through. What did I do? I used the distributive property. Okay, something that you want to keep in mind when you're doing 2-column proofs. Number each step for me and line up your steps. So I have 1, 2 is right next to it, so I can just read. Don't cram all your reasons up so that your last statement's down here, but your last reason's up here. It's going to be hard for me to read that. Next step, 3. Okay, combine like terms. 10 minus, or negative 6a minus 4a. I always like to do the variables first. And then we have minus 18 is equal to a 98. And that is combined like terms, I'll say. I know that that wasn't one of our official reasons. The next reason. Okay, we would add the 18 over. I don't know why this changed to a 98, because I wanted to mess with myself. Because I keep looking at my notes. I think I was looking at that. So I add that over and I get 110, and that's our addition property. Step 5, divide by a negative 10, and that's our division property. Okay, so again, two-column proof starts with the given. Typically, in a two-column proof, you're going to have a given and you're going to have a prove. And you'll see one like that later on in this lesson. But go through each step, justifying, making sure your statements and your reasons line up. Statements are always on the left, reasons are always on the right. Okay, and numbering each step for me. Okay, example 3. We're given this formula, and to convert from, and this is from Fahrenheit to Celsius, and then this is the conversion from Celsius to Fahrenheit. Write a two-column proof to verify this conjecture. A conjecture, remember, is an educated guess. I've been using that term, I believe, a few times with you. So we start with this. And that's our given. What did I not do? I didn't number my steps. I want you guys to number your steps for me, please. Second step. I'm going to show some algebra in here. I'm going to multiply by 9 over 5. So I get 9/5 C equals F minus 32. And that second reason is multiplication. And you can simplify, you can abbreviate multiplication, as in multiply. The third step, we're going to add 32 to both sides. And that was addition. Technically, I would be okay with this, but I want to show you the next step that gets us exactly to what we needed. That's that symmetric property. That's how we would use that. Honestly, what do they call it? They call it symmetric. Honestly, I would be okay if you left it at step 3. Again, let me re-highlight. I'm listing all of my steps. I'm going through, and step 4 lines up with reason 4. Step 3 lines up with reason 3. Step 2 lines up with reason 2. Okay, make sure they line up for me. It helps me in grading, and I might even take points off. Okay, the next one. So I have F, G, J, congruent to J, G, K. J, G, K, congruent to K, G, H. And then I have some measurements. I need to prove that x equals 6. They have a diagram here for me. One thing that's helpful in proofs is if you mark up your diagram. So F, G, J is equal to J, G, K. Since those are equal, I mark them just with each with one mark. J, G, K is marked with one mark. That's congruent to J, K, G, H. So I'm going to mark that also with one mark because it's already marked. Okay, so now what I'm going to do. Let's start our proof. Again, you always write your first step is always your given. Typically, I tend to write out the entire given. I'm not going to in this point because I want to show you guys how you use your given to get your next step and how that diagram is going to help us. Okay, so that's my given. Notice how when I marked up my diagram, JGK was congruent to two different angles. So then by my transitive property, I can say angle FGJ is congruent to angle KGH. And that's the transitive property. And the diagram, when I marked up my diagram, that helped me out. I marked this one with 1, marked that angle with 1. I've already marked this with 1, but that's also equal to that one. So I knew from my diagram that all three angles were going to be equal. Now we have to use the next part of our given. Write the next part of your given. I apologize, I was looking at what was above. Now what I think our book does is they say that these are now equal by like definition of equality. I'm just going to use substitution. I'm going to substitute in the 6x plus 7 for the angle FGJ. So 6x plus 7. KGH, I'm going to plug in 8x minus 5. Again, that was substitution. I am going to show all steps in solving my equation. I know that some of you could do this in multiple steps. So I'm going to add 5 to both sides. And that's addition. And again, you don't have to write addition, you can write add. And our book says like addition property of equality. I'm okay with just addition. I subtract 6x to both sides. And that is subtraction. If you want to abbreviate subtraction, abbreviate it to that. Please don't write SUB because that could also be substitution. Let me actually highlight those. So that's my substitution abbreviation. That's my subtraction abbreviation. Notice the difference between those. And then our last step here is division. If you want to flip the sides, if you want to flip them and use symmetric, you can. I am not going to take off if you don't flip the locations of them. I'm okay with you leaving it x equals 6 equals x. Okay. Okay. So that is what I had for you guys for today. Our algebraic proof. Thanks for watching.